Hello, good morning again. Welcome to my channel JBTeguihanon Engineering and Chemistry Tutorial. So today we are going to continue to solve another example, kinetic energy example. Okay, so let's jump in. So here is the example. So a 10-kilogram body falls from rest with negligible interaction with the surroundings, no friction. Determine its velocity after it falls 5 meter. So suppose you have a body which is at rest, okay, and it falls to the ground. Okay, this is your body. It has a mass m. It has this one, shall we say, h2, and this is h1, the height. Okay, so with this you have, of course, the potential energy, right? So this one is 5 meter. Sorry, this is 5. I'm going to erase it. This is 5 meter. Okay, bear with me. That's my 5. So in this case, we got to have this principle here. The conservation of energy demands, okay, the conservation of energy demands that what it demands that the initial energy of the system equals to the final energy of the system. So if my body is there and it has h1, h2, after 5 meter it falls, determine the velocity. Okay, this is body with a mass m. So what he's saying here basically is that E, energy 1, okay, is equal to energy 2. To analyze this, you got to use this conservation of energy principle. Otherwise, you have no basis to analyze, right? So you got to have that not assumption but statement of equality. So energy 1 is equal to energy 2. That's the best thing we can not assume but we can state, right? Now with this, energy actually is equal to kinetic energy and potential energy. You have a potential energy here because of the location, 5 meters from the ground, because it's falling. So you can say that kinetic energy 1 plus potential energy 1 is equal to kinetic energy 2 plus potential energy 2, right? So we have no space, so I write it like that way. Okay, so if we plug in the formula, then we have 1/2 I just want to put divider here. 1/2 mass v times the velocity square plus potential energy, which is mass times g times h. This is your h1 initial condition, and then you're gonna have, and this is gonna be equal to your energy to 1/2 of the mass. That is actually the same mass, but their velocity is not. Mass g and then h2. So this is h2. We don't have space. And then we're gonna analyze this. Of course, the initial velocity is 0. This initial velocity is 0. You have no velocity when you start, right? That's why you're starting, right? And then the elevation, this elevation here, pretty clear or very clear. This elevation you have is actually equal to 5, meaning h1 minus h2 is equal to 5, right? That is what we see from the by inspection. So our equation, this equation here that we have, right, coming from this statement of conservation of energy, we don't account the internal energy here, because generally E is equal to kinetic energy plus potential energy plus internal energy, U. Okay, in the previous, this is 0. In the previous example we have, and we had been asked to solve for internal energy. Okay, but today internal energy is 0 because it doesn't collide to anything, right? That's what this state problem says. We don't even consider the friction. So after analyzing, we are now coming into the expression of m, quantity h1. So you know your algebra, you do the simplification and you come up with this, right, is equal to 1/2 of the mass m times the square root of the velocity 2. Remember, you don't have initial velocity. Okay, your v1 is 0. So he's asking for what? He's asking for the velocity after it falls 5 meters. So furthermore, your velocity 2 is equal to square root of 2g h1 minus h2, which is actually 5. That will give you square root of 2, 9, oh, sorry, I'm jumping in. That is actually 2. I change the color so that you can see it clearly. 2 times 9.81, the G is 9.81, multiplied by 5. Okay, of course that is under the square root. Okay, so to save our I cannot write down here. To save our space, I'm going to write down the answer. Yeah, here. Can I do that? Yeah, here, like that. So we have a partition here. Your velocity is equal to 9.9 meter per seconds. So that's the answer. With that initial condition, okay, actually in this case, gravity doesn't count, right? Because you are dealing with the same mass, so your your m here was cancelled out, right? Right? And it has g here. I forgot to write down. This is mass times g, gravitational acceleration here. Okay. So this is actually m times g multiplied by quantity h1 minus h2, 1 half is equal to 1 half mass times the velocity square. Okay, and then you have this final answer, 9.9 meter per seconds, after reaching this 5-meter elevation. Or okay, I hope you learned something today. That's all for now. Thanks for watching. Please subscribe to my channel, JBTeguihanon, Engineering and Chemistry Tutorial. God bless.